2.3 periodic table. First, we need to talk about how the periodic table is arranged. So the periodic table for today, the modern periodic table, is arranged by increasing atomic number. So if you were to look at it, it's going to start with atomic number 1, 2, 3, 4, 5, 6, all the way down to 118. Okay, so it's in order by atomic number. Now, parts of the periodic table. You have what's called groups and periods. Groups are your columns. Groups are your columns, so those are what goes up and down. So groups, right here, these are your groups, your columns. All right, so there are 18 columns in the periodic table. Now, if an element is in the same column, they have similar properties. The reason they have similar properties is because they have the same number of valence electrons. Okay, so similar properties because they have the same number of valence electrons. So here, everything in group 1 has 1 valence electron and so forth. Okay, periods are your rows. Periods are your rows. Rows. So hydrogen and helium are on the same row. Lithium, beryllium, boron, carbon, so forth are on the same row, so they're in the same period. Okay. When you write a sentence out, you have to go across to put the period. They go across. They change properties. Okay, so properties change as you move from left to right. The one thing they do have in common is they have the same number of energy levels. Same number of energy levels. So when we were doing Bohr's diagrams, however many rings there are, that's how many energy levels there are. It depends on what period they're on. So if we were to draw the Bohr diagram for lithium, it's in the second row. Therefore, it has 2 energy levels. Sodium is in period 3, so it has 3 energy levels and so forth. Okay. Now for this next piece, you should already have at least like 10 different colors here. You have a periodic table as well. You're going to color in your periodic table similar to mine. You don't have to use the exact same colors, but you need to label exactly like I have it labeled. Okay, so the first group, this group right here, not including hydrogen. So you're skipping hydrogen. This first group right there, excluding hydrogen, are known as the alkali metals. So group 1, alkali metals. Next thing, the second group. Second group are known as your alkaline earth metals. Next thing, this chunk in the middle, these are known as your transition metals. The reason they're called that is they are literally the transition of the periodic table. You're going from this chunk of the periodic table to this chunk. So these are the transition metals. Okay, you can color more neat than that, but I'm just trying to get through it quick. So these are your transition metals. Next, you have what's called your other metals. They don't really have a special name. Now you need to make sure you're coloring in the same ones that I am. So it's kind of like that. Okay, kind of looks like an L, but then you include SN in there. They don't have a special name. They're just sort of the other metals. All right, then group 17, and it's called group 17 because it's the 17th column. Group 17 are your halogens. When halogen light bulbs, they contain one of these things in them. So halogens. And then last group, group 18. These are known as your noble gases. They are the kings of the periodic table. All other elements want to be like them. They are the most stable elements on the periodic table. Okay, they are the noble gases. And then last, these bottom two rows, they're actually a part of the periodic table. It's not like they're excluded or anything. They've been brought down to the bottom just to be able to fit into a textbook, okay? They are called your inner transition metals. Inner transition metals. Why are they called that? Because actually they literally do fit right into there. They fit into the, well, here, sorry. They actually go there between, if you were to actually spread it out, those two rows fit into that chunk. It would just take up more room than what a textbook would be able to fit. Now, they are actually more divided up into lanthanides and actinides, and that's simply named based on the group that it's next to. Okay? Now, what we're going to do here, you're going to use that exact same periodic table that you have, and instead of coloring in like we just did, you're just going to simply outline with the same color that you put as your key. So, you have what's called metals, metalloids, and nonmetals. What you're going to do first for me is you're going to draw this staircase thing. Okay, this staircase, you're going to take a black marker or a black crayon or whatever you have, and you're going to start between boron and aluminum, and you're going to draw this lovely staircase. This staircase separates your metals and your nonmetals. Everything to the left is a metal, everything to the right is a nonmetal, except for hydrogen. Okay, so metals, sorry, I'm trying to choose a color here. Metals, you need to make sure you have your key. Metals is going to be this big chunk here. And you're simply going to outline where your metals are. Just outline, just like that. And then this chunk at the bottom. Those are your metals. Use a color you didn't use before. Okay, then you have your metalloids. Metalloids, now they're kind of in the middle here, just sort of outline each individual box. Metalloids, you see where they're located? They are sitting literally on top of the staircase. Okay, they are on top of the staircase, and then GE and SB on the bottom. These are your metalloids. Then, pretty much what remains are your nonmetals. Nonmetals. Everything to the right of the staircase. Everything to the right. And then also hydrogen. Something else that you can do on your periodic table if you want to add more is simply write metal and nonmetals. Okay, remember it's all about that staircase. To the left metals, to the right nonmetals. All right, now we need to talk about some properties of metals and nonmetals. So let's talk about metals first. Metals, they usually have 1 to 3 valence electrons. So what this means is their outer electrons are up for grabs, or they can be add more and so forth. They lose valence electrons. Good conductors, malleable. This just means they can be beaten into thin sheets and they won't crack. Like glass, you can't hit glass with a hammer without it breaking. Ductile, can be stretched into a wire. Luster means it has a shine. If you buffer it, it has a shine to it. Most of them, not all, are solids at room temperature except for mercury. Okay, nonmetals, complete opposite. If you can remember one, then you should be able to remember the other. They have 4 to 8 valence electrons. Now, because of that, they're going to gain, because they already have some. They want more. They're greedy. Nonmetals are greedy. They want more. Now, they gain or share. They're poor conductors. Brittle, this just means that they break easy. They're breakable. Non-ductile, can't be stretched. Do not have shine. They have no specific room at they have no specific state at room temperature. Yes, a lot of them are gases, but not all of them are gases at room temperature. Metalloids. Metalloids have variable properties. They can act like metals or nonmetals. They act like metals when they react with nonmetals, and then vice versa the other way. They have semiconductor properties, meaning they can kind of conduct electricity, but not really. Okay? Now, the next few slides are about the trends that happen in a periodic table. You need to know the definitions, and you've got to be able to figure out which element has more of that topic that we're talking about. So the first one, ionization energy. Energy required to remove an electron. So how much energy it takes to go in and snatch an electron out of that atom. It increases up and to the right. So what's going to happen here, you need to draw this in your notes. This is our lovely periodic table. It increases up and to the right. So you're just going to draw arrow, increases up and to the right. That means this point here has the most. So the furthest up and to the right has the most ionization energy. The closer it is to that top right corner, the more ionization energy. The harder it is to steal an electron away. Electronegativity, these big long words, you got to know them, is the ability, you don't need to know all that, just the ability to attract electrons. Okay, ability to attract electrons. It also increases up and to the right, up and to the right. Only exception, group 18 has 0, has none. Group 18 does not want to attract. They're kings. They don't need more electrons. They are perfectly happy the way they are. So other than that, increases up and to the right. Again, furthest has the most. So this guy down here has hardly any at all. He's tiny when it comes to electronegativity. He can barely attract anything. All right, so most unattractive atom is that one right there. Most attractive is fluorine up at the top. Atomic radius. Radius should be obvious. We talked about it in math. Radius is the size of a circle, so atomic radius is the size of an atom. Now this is the one that's completely backwards. It actually increases left and down. Okay, so this guy here, this atom, is the biggest atom when it comes to volume of the atom. Okay, so this is the biggest. Okay, when it comes to volume, it has the largest radius. All right, now you don't actually have to draw this. You're not coloring or anything like that. You just, what I have written here, you need to write in your notes. So group 1 are the most metallic elements and the most reactive metals. So reactive that they do not exist in nature without being bonded to something else. So sodium, for example, if it were to rain and it's by itself, you would have many explosions going on everywhere. Group 17 are the most reactive nonmetals. That's why a lot of times group 1 and group 17 are together, because they're both highly reactive. Group 18, so this is group 18 down here, are the most non-metallic elements, and they are non-reactive. Most of them do not want to be around anything else. They are by themselves and perfectly happy. They are extreme introverts. They do not want to go anywhere outside of themselves.